Hello everyone. In this video, we will continue to examine topic 7.3, the structure of matter, and in particular, we will continue to unpack some Feynman diagrams. Alright, so here we have a selection of Feynman diagrams, just to get a sense of the variety, and then we'll go through the interactions one by one. But take a look at this. First, this is our sort of the first Feynman diagram that we encountered, and so I won't spend too much time on it, but notice that the way we might describe this is two electrons scattering off of one another, being mediated by a photon. So this is an electromagnetic interaction mediated by the emission of a virtual photon, an exchange particle, that is the gauge boson of the electromagnetic interaction. We also saw in the last sort of slide the pion mediating the residual strong interaction between this proton and this neutron. As it turns out, this is an example of an interaction where it's not obvious that these particles aren't scattering off, but this is the kind of interaction that also represents an attraction. And that is sort of a semi-flaw of interpreting the Feynman diagrams too literally, but this particular interaction is occurring between the proton and neutron to bind them together. Now, up here in the top right, we have a kind of interaction we haven't seen before, and that is an example of a direct weak interaction. So in this particular case, you have a neutrino. Remember that neutrinos, as leptons, do not interact via the strong force, and the neutrino is also neutral, so it is not going to interact via the electromagnetic force either, which means the only way for this neutrino to interact with this neutron over here is through the weak interaction. And in fact, this is how we detect neutrinos. The neutrinos have to be incredibly close to the nucleons for us to see this sort of interaction. As I've mentioned before, trillions of neutrinos are right now passing through every square inch of your body, coming from the sun. But in any case, when they do interact, the way they might interact is through this neutral weak gauge boson, the Z boson. Sometimes this can be called a neutral current interaction. So just be on the lookout for that bit of terminology. And in this bottom right-hand corner, we can see a direct strong interaction between quarks. So in this particular case, an up quark is emitting a gluon directly, and that gluon is being absorbed by a down quark. And the gluons mediate the strong interaction directly between quarks. One of the reasons you haven't seen the gluon before now is that this gluon right here with this loop-de-loop shape is actually not assessed in the IB. So I include it here for completeness, but you will not be asked about direct gluon interactions between quarks.